I'm Corrion. I'm CTO of IOTech. Pleasure to be here. Thank you, Johan, for inviting us and letting us participate, be a part of the end-to-end solution as well as be a part of today's activity. If you were to put us in a box, the edge is the best box to be put into. Right? We are a middleware company. We're a software company. We have packaged software products. We also have a professional services team that we work with, Acuvate and others to integrate our software into their solutions. Today our business is very OEM driven. We have very large globals that adopt our software and internal integration teams build it in and deploy it as part of their service offerings. So today's examples, because of confidentiality, I won't be able to give a lot of names, but almost every example I'm giving today is based on one of our customer situations, customer challenges, and the reality of deploying edge computing. So we're going to talk about the edge, we're going to talk about the challenges of the edge, and we're going to talk about how we help solve them for you. So I don't know where everybody's background is on this, but walking into this building, walking out of the hotel this morning, going to the airport, embedded computing is everywhere behind the walls, everywhere that you've traveled, everywhere that you've gone. In this building, I'm certain there's a closet that has something that looks like this, a couple of computers stacked up, some security cameras cabled into it, probably thousands of dollars of vendor contracts for, if not initial investment, but annual maintenance for these kinds of systems. So embedded computing is there for decades, and it's hidden away, and the vendor contracts are hidden away, and the problems are solved. And as long as you don't want to change anything, there's no problem at all. We want to change things. So the change that's coming is as we move to the cloud, this idea that let's just put everything in the cloud. We'll move all our infrastructure to the cloud. We'll take out our servers. We're not going to have servers in the data center. We're going to put them in the cloud. We're going to take away our tablets and our banks. That's our PCs and the banks. We're going to have virtual desktops so bankers don't have to worry about PCs being stolen, confidential data being stolen. So we're moving to this cloud-centric world. And when you get cloud-centric, you get data-centric. What are we going to do with the cloud? Well, if we don't get that data there's not much to do. Then you get a little hungry. Say, okay, we got all the data we have. Where's the other data? Well, the data's locked in the factories, locked in the production platforms, locked in the buildings. And so the edge now is everywhere the cloud isn't. This is it's a flexible term. Right? For me, it's easy to say the factory has a PC, the AnyBot robot is edge compute. It's doing analysis on the data it's collecting. I was looking at the valve. So there's edge compute in the AnyBot robot. So the edge is a very flexible term relative to where you're trying to do the analysis. And you're going to go through a set of questions to decide what is your edge, right? In this case, can you just move your data to the cloud? Johan was mentioning 5G connections with low latency, high bandwidth. You can actually do a lot. If you can confirm that connection is stable enough for you, then you get your data to the cloud. Maybe it's a latency problem. Can your decision that needs to control a machine get back to that machine fast enough to be responsive? Do you have security issues? Do you need to keep data on site because you just cannot risk that data getting off site? Right? Another one is maybe you have diverse requirements. What I mean by that is we want to get that data off for analysis. There are things we can do with the cloud, but you may need a 12-month rolling history to defend a customer warranty claim on your equipment. And that data has to stay in the machine that you're defending, right? And it has to be protected from various users. So edge computing can be simple. We're just going to help data move to the cloud. Or it can be quite complex because these requirements pile up pretty quickly. And here's an example of the edge being way over there, right? The problem with the edge is once you decide you can't do it in the cloud, it's probably someplace that's quite difficult to access. You may not have employees there, you may not have transportation easily to get there, and so you have new challenges that you have to worry about. But the point is we've got to put that compute where the data is at the cost that justifies the analysis. It may be as simple as filtering data. Modern cars, if you were to sample every sensor, could have about 4 terabytes of data produced per day. So you're not going to move 4 terabytes of data per car to the cloud every day. You're going to make decisions about what you filter, what you choose to analyze, what you choose to act on in the car. That's edge computing. Same thing for an oil platform. There are so many sensors on that thing, you are not going to move all that data to the cloud, even if you had perfect network connectivity. But I think a good example is the battery farm. So this is a fake picture, but essentially batteries are delivered in containers. They're attached to the grid. Each container is full of hundreds or thousands of tiny cells, about the size of a couple packs of cards, 20 cards. Each one you have to measure constantly its voltage, its current state of charge, whether it's charging, whether it's discharging, the current going each way. And you store that for all sorts of reasons. We have one customer who's collecting roughly 40 million data points per minute per battery. Right, we have another customer who's using this to store all the data points for that 12-month rolling window to show that their battery is performing under the warranty investigation, as well as they promised how many charge-discharge cycles that customer would get. And I need to say that, wow, we built this battery for you to last 12 months with this charge-discharge rate. Or 6 months into the year, you've used 80% of your charge-discharge ratio. So something's wrong. Either our sales team misquoted what we're offering, or the customer's actually using the product differently than expected. So this has to be done on site. Compute is embedded inside those containers, right along those battery cells, in order to get this done. And they have to be able to manage that remotely. They have to have local control, automated edge computing, looking at data, making decisions, as well as storing for future use. So the takeaway for this section, the edge is a perspective. Embedded computing is not new. The term edge is new, and it's really just to help you clarify where is the data coming from and how close does my compute have to be invested to utilize that data, the source of data. So let's get to the challenges. There's a lot of fun transitions going on right now. So servers, most companies are trying to move servers to the cloud. There's only a certain few situations when you're such a stable processing environment, you can keep your server local. IT, desktops, laptops, same thing I see in this room, people using iPads, taking notes. They've already replaced their PCs. When you get into productivity applications, used to be all self-hosted by companies, now we just outsource cloud-hosted SAP, cloud-hosted Office 365. We're moving outsourcing responsibility from our teams to these other parties. So when you get to the embedded compute area, okay, well, we're moving to the edge, but we really don't know what that means as a team, as a set of responsibilities. What does moving to the edge mean? And really, it means we're changing practices, and this is going to create some conflict. So Microsoft, a couple of years. Sorry about this. I mean, Microsoft voted about the blasphemy. But Microsoft actually runs the world behind the scenes. If you go to an airport, every digital sign that's hanging from the screen has a small Microsoft-based PC running that sign. A lot of our factories are still running Microsoft. You can go into a 30-year-old, production factory. I was in Brazil, a sugarcane refinery, and they had this Windows PC that if it crashed, the factory goes down. But that one PC was running the entire refinery. With one old PLC, programmable logic software application running on top of it. But Windows is probably running in this building itself to run the building automation for the building. So it's there, and this is what our current teams are supporting. When we talk about the edge, we're talking about using the same technologies as the cloud. We're talking about going DevOps, we're talking about using containers, orchestration, platform engineering, all these buzzwords that reflect the energy of the investments going into all cloud-based applications. Lastly, AI data flows and data architectures, event-driven applications. These are things that redefine teams as they move their software applications to the cloud. And so we have a problem though. So cloud native, we deploy compute infrastructure, right? We're dynamic. If we have a problem, we deploy it, we fix it. Embedded compute, the response is about static. Nothing changes. Nothing breaks. No accidental configurations that take a system down. We have SLAs, and we have vendors, we have support teams to keep this operational. But these very technologies we're trying to adopt are based on ship it, break it, fix it, these really fast experimental environments, right? And so we have teams that share knowledge, we move fast, we break things. On the embedded side, we built entire departments and vendor agreements to not change anything, right? We really don't want to change anything. And heaven forbid if we actually hired someone who knows how to do these things, I don't even know if they would stay in our department. Right? We've had customers tell us, don't use the word Kubernetes, because if you can train our employee how to use Kubernetes, we will lose that employee faster than we can even hire them. Right? So there's this weird threat to this new technology in existing organizations. And ultimately, this is what the challenge is. We've got decades of deployments. We've got decades of vendors who have sold us solutions that work, and they work well. We've got tens to hundreds of vendors. We have hundreds to thousands of devices per site. And we have interoperability standards that are lacking. There's no motivation to pull these things together. And so basically it boils down to the data's there, but it's hidden. It's locked away behind all of these market reasons that have gotten us to the successful infrastructure we have today. So this is where we try to come in and help. We try to address all these challenges we just gone through. We built our software on EdgeX Foundry. EdgeX Foundry is an open source project. It's hosted by the Linux Foundation, in particular a sub-umbrella project called the LF Edge. This wall of logos is to impress you that the open source project is well supported. It is. It was founded about 2018. It's meant to be vendor neutral and meant to be the place that we can bring everybody's protocols into one platform where you can build on collaboration and build on consuming data wherever you're consuming at the edge. It's a typical northbound, southbound architecture. So if you've seen a diagram like this in the past, EdgeX has core services, the blue bar in the middle. Everything above the blue bar is how we get data up to the cloud or up to a consumer. Everything below the blue bar is how we collect data from the various devices. So all the protocols you're comfortable with, LPCUA, Modbus, BACnet, even simpler ones, MQTT, Sparkplug. We have connectors for all of those, as well as simple and RESTful connectors for just integrating random data. But we also have outbound connectors ready for cloud export, as well as rules engines and application services that can be managed, configured, or compiled to act on local data coming through the system. So the whole idea, though, this is built like a cloud application. It's disaggregated, it's loosely coupled, it's built on microservices. So if you don't need those pieces, you don't deploy them. It makes it easy to also scale deployments. If you have that many more Modbus devices, you can deploy more Modbus device service connectors. So it makes it easy to flex to what you have to deploy to. But with that flexibility comes a little bit of a challenge, because now you have to curate. You have to decide what you're going to deploy. And that's where the IOTech team can help. That's where the Acuvate team can help when you have to make these decisions. Here's the exciting part. It's an open source project. The first few years of its existence, it was really building a capability. And so, no reasonable company is going to adopt something with a 0.1 version number. And we released a 3.1 version in the last 12 months. We also released the first long-term support, long-term stable LTS version, which gives people comfort that we'll have 2 months of stability with that particular version. And in this year's board elections, we have a technical steering committee. We actually have 3 end-user representatives on here. So Eaton, Danfoss, and Schneider, as well as the Chinese company Ekisoft. 4 end-user companies who have adopted EdgeX as part of their core investments. So if you're consuming Eaton products, Schneider products, or Danfoss products, you may already be, or you're on the roadmap to consume EdgeX, whether you know it or not, inside their product offerings. So that's a pretty exciting moment because it's shifted. We're no longer building capability, we're now building stability, and we're building for deployments. We see 3 adopter patterns with this technology. One is for internal standardization. So we have a major manufacturer of industrial bearings. They said they had roughly 250 innovation teams, each building their own edge platforms for their application. So this allows them to consolidate their internal innovation teams onto one platform, delivering all of their internal value. Most of our business is with OEMs who are deploying external service offerings. So just like Eaton, Danfoss and Schneider, who are deploying their products across their customers, they're using platforms like EdgeX to corral all of their internal value creation for the services they're offering. And the third is growing. We'll have more news hopefully within the next 12 months, but we have a few companies that are doing this across industrial verticals. So creating an industrial standards body basically to say, okay, if we're going to do edge computing, we want all our vendors to land their services on this platform. But it's consistent reasons. We're normalizing the data. When it comes through this platform, regardless what protocol the data came from, the data comes through and exported in the same data format so that all applications can expect a consistent format for consumption. We can use standard integrations for APIs, for services, and so on and so on. But overall, it's about reducing cost, increasing speed of integration, and reducing technical debt. Because there's parts of this platform you don't have to own just to focus on a little bit of value-added edge computing your situation requires. So we offer something called Edge Central. This is the product name. It's built on EdgeX Foundry. EdgeX Foundry is the open source project I just responded to. Edge Central is a pretty classic business model where we take the open source project, we provide industrial grade support. We have 24/7 global support offerings for this. We also have built software around EdgeX so that we add additional capabilities, scheduling, alarm management, system management. We have increased the ability to do edge applications through configuration beyond what the open source solution offers. At this point, what we watch our customers do, they're still solving protocol problems. They still have performance issues with particular connectivity protocols, and we watch them have tagging problems. If anyone has ever looked at a fleet of devices and figured out how do I tag these consistently, whether it's a building or whether it's a production facility, this is one of the biggest issues. And so they're using our platform to normalize tagging and move towards things like unified namespaces. So in one slide, we have a base product called Edge Connect, which very specifically focuses on high performance, high reliability data connectivity, deeply embedded in your software. Most customers don't need this, but if you do, it's there. But what most people do is they adopt Edge Central, which is the EdgeX platform, and that's where we embed our connectivity offerings. Right? So we have a team focused on those protocols, and then we have a team focused on the EdgeX platform and making sure that's a channel of value to the customer. Both of those can be deployed directly to factories or to the field. We have scale deployments from both. Big energy opportunities, a lot of battery energy storage, also a lot of building automation. We'll get to both of those use cases in just a second. And then finally, we have a product called Edge Manager to help offload the requirements to manage a fleet of thousands of edge devices. So this is a little bit different than just going into Microsoft Arc or any kind of Kubernetes solution. It's not strictly container management or application management. We have to worry about the metadata of these devices. We have to worry about the configuration of these devices. Every site is unique, and this tool is trying to be ready for the edge native user. So battery energy and storage, I used a couple of verbal examples earlier. We have customers using this basic architecture in two different OEMs that are producing battery systems. But we see that same northbound, southbound type thing going on here. We have Edge Central acting as this bar in the middle, collecting data from all the devices attached to the battery underneath. And then we have data being conducted up to the various local systems or remote systems, historians, SCADA systems, whatever it takes to keep these applications running. The other interesting one is building management. So it used to be a very boring situation. We had building automation systems from folks like Honeywell, who have been deployed for decades, adopted for decades. but they have very high price tags and they have very small data sets. And we have a lot of new opportunities where people are coming in and offering to arbitrage the cost of producing steam or to produce chilled water. They recognize that notional or intuitional based control strategies aren't as efficient or cost effective as using AI or algorithmic strategies. And so they come into a building and say, we'll happily take over chilled water production for you. We'll split the difference on cost. This is not a new business model. They did it for LEDs for years, now it's moving on to other energy consumers. But they say, but we need your data. And the buildings, well, we don't have the data. We've got 50 data points from 50 thermostats that we have across our building. Okay, well, we need more data. And so that's where we come in. We can attach to an existing building management system, use the data that it's producing, as well as attaching to the other data points that are present, providing the frequency and the volume of data required for these algorithms to train and ultimately deploy and control the production of steam and the production of chilled water. So it's kind of exciting. We have very small customers doing that. We have very large customers looking at the same exact problems. And so in a nutshell, that's how IOTech is trying to help. We're a middleware company. You typically wouldn't hear our name. You might be using our software, you wouldn't know it. But we're here to help solve your problems. So if you hear the problems of edge computing, you hear the problem of data connectivity, protocols, you have these challenges, then go to Acuvate. Acuvate will help us help you pull through our capabilities.